Hello viewers, today we will solve this integral and the integral is from 0 to pi x sin x divided by 1 plus 3 cos square x, right? So let us solve this integral. So let us first call this integral as I, and in order to solve this definite integral we'll make use of one important property of definite integrals, and the property is if we have the integral from 0 to a f of x dx, then this can be written as integral from 0 to a f of a minus x dx, right? So here we'll apply this property to this integral. So the integral becomes 0 to pi, and here the value of a is pi, and the function f of x is given by x sin x divided by 1 plus 3 cos square x, right? So now this integral becomes pi minus x sine pi minus x divided by 1 plus 3 cos square pi minus x, right? Okay, now from trigonometry we know that the value of sine pi minus x is sine x, and the value of cos pi minus x is minus cos x, right? So the integral becomes 0 to pi, and here we have pi minus x. Sine pi minus x is sine x, and here we have 1 plus 3 cos pi minus x is minus cos x, and the square of minus cos x is positive cos square x, right? Okay, now let us split this integral into the sum of two integrals, and we can write this integral I as 0 to pi pi sine x divided by 1 plus 3 cos square x dx, and minus 0 to pi, and we have x sine x divided by 1 plus 3 cos square x dx, right? Now we see that this integral is I, so here we substitute the value of this integral as I. So we have 0 to pi, and here we can take pi out of this integral sign, so we have sine x over 1 plus 3 cos square x dx minus I, right? Now taking this negative I to the left hand side, we'll have here I plus I is equal to pi 0 to pi and sine x over 1 plus 3 cos square x dx, right? And I plus I is 2i, and taking 2 to the denominator of pi, we have I is equal to pi over 2 and 0 to pi sine x divided by 1 plus 3 cos square x dx, right? So viewers, the given integral is now reduced to this integral, right? So let us now solve this integral by the method of substitution. Now here we see that the derivative of cos x, it exists in the numerator, so let us substitute t is equal to cos x, right? So dt is equal to minus sine x dx, and we can write minus dt is equal to sine x dx, right? So for this sin x dx, we can substitute minus dt, and here we see that the limits of integration are from x equal to 0 to pi. So let us change the limits, because we have changed the variable from x to t, right? So when x is equal to 0, then the value of t is given by cos of 0, and cos of 0 is equal to 1. And when x is equal to pi, then the value of t is cos pi, so this is minus 1, right? So when x goes from 0 to pi, then t goes from 1 to minus 1, right? So now this integral I is reduced to pi over 2, and here we have the limits from 1 to minus 1, and for sin x dx we can write minus dt, and in the denominator we have 1 plus 3 t square, right? Now taking 3 common from these two terms, we have I is equal to pi over 2, and now if we take 3 common, then we have 1 over 3, and we have the limits from 1 to minus 1, and this is dt, and we can also take this negative sign outside this integral, and we have 1 over 3 plus t square, right? So now we can further write it as minus pi over 6, and this is 1 to minus 1 dt over t square plus 1 over square root of 3 whole square, right? So we have now written 1 over 3 as 1 over square root of 3 whole square, right? Because we know that the integral dx over x square plus a square is equal to 1 over a tan inverse x over a, right? So we are going to use this result to evaluate this integral, right? So now I is equal to minus pi over 6, and here for a we have 1 over root 3, so here we have 1 over root 3, and tan inverse for x we have the variable t, and for a we have 1 over root 3, right? And the limits of integration are from 1 to minus 1, right? So now this can further be written as minus pi root 3 over 6, and this is tan inverse t root 3, and the limits of integration are from 1 to minus 1, right? Now we can simply substitute the values of the limits in this expression, and we'll take the difference. So I can be written as minus pi root 3 over 6, and we have tan inverse for t is equal to minus 1. Here we have minus root 3, and for t is equal to 1, we have tan inverse root 3, right? Now this is minus pi root 3 over 6, and tan inverse minus root 3 can be written as minus tan inverse root 3, and here also we have minus tan inverse root 3, and this is minus pi root 3 over 6, and minus tan root 3, tan inverse root 3 minus tan inverse root 3 is minus 2 tan inverse root 3, right? And tan inverse root 3 is pi over 3. So we have here minus 2 times pi over 3, right? Because tan pi over 3 is equal to square root of 3. Now simplifying this expression, here we have will cancel this 6 by 2, so here we have 3, and minus multiplied together becomes plus, so we have pi square root 3 over 9, right? So the value of I is equal to pi square root 3 over 9, and we can further write it as multiplying the numerator and denominator by square root of 3. So we have pi square root 3 times root 3 is 3, and here we have 9 root 3, and we can cancel it out like this. 3 3s are 9, so we have pi square over 3 root 3, right? So the value of this integral is equal to pi square over 3 times root 3, right?